Connection shown in this figure is one of the way to connect three-phase generator to the load. As you can see, this connection requires 6 wires to connect. The 3 single-phase circuits shown in this figure are electrically independent. But if you observe the image carefully, you will find that we can combine the 3 return conductors together to form a single return conductor. By doing this, we have saved cost of 2 conductors as the number of conductors are reduced from 6 to 4. And that's a great saving. Now, this common return conductor is called as neutral conductor. It carries sum of 3 currents, that is IA plus IB plus IC. At first, many of the people will think that the conductor required for neutral should be 3 times in the size than the other 3 conductors, as it is carrying sum of all the 3 return currents. But as we know, current of the 3 phases are out of phase by 120 degree from each other, and if we draw a waveform for this current, it will look like this. Now, if you observe the diagram carefully, you will find that the sum of return currents is 0 at every instance. For example, at instance corresponding to 240 degree, IC is equals to maximum. IB and IA is equals to minus 0.5 Imax. So if we add these return currents, we will get sum equals to 0, and this is true for every instance. We can therefore remove the neutral conductor without affecting the voltage or current in the circuit. So we have reduced the number of conductors from 6, which was the initial stage, to 3. 50% saving in conductor cost. However, the load shown in the circuit must be identical if you want to remove the neutral conductor. If your load is not identical, then removing neutral conductor can cause unequal voltages across the load. So, in an ideal situation or in the situation where load is equal, current flowing through neutral conductor is always 0. And this is a very commonly used question in technical interview. The conditions where load is not equal, a neutral must be provided. You might have heard people saying 3.5 core cable. That 0.5 core is your neutral conductor. The circuit shown in the figure is called as 3-phase 3-wire system. The generator and the load are said to be connected in Y, as it resembles the letter Y, or some people also called it as a star. The figure shown is called as 3-phase 4-wire system. The neutral conductor can be of similar size or maybe slightly smaller than the other conductors. 3-phase 4-wire system is widely used to supply power to commercial and industrial customers. Now when we talk about star connected 3-phase system, there come 2 concepts: line to line voltage and line to neutral voltage. The voltage between A and N is called as line to neutral voltage. Similarly, a voltage between A and B is called as line to line voltage. Relationship between these voltages as well as the current changes with the type of connection. So it is important to understand this relationship for different connections. In case of star connected system, line to line current are equal to line to neutral current. But in case of voltage, it is different. Consider the winding shown in this figure, which is connected in star. As you can see, the conductors are placed 120 degree apart from each other. So if you apply Kirchhoff's voltage law to this circuit, and by doing some mathematics, you will find that the line to line voltage is therefore √3 times the line to neutral voltage. So you can write EL, which represent the value of line voltage, equals to √3 times ELN, which is nothing but the line to neutral voltage. One of the other way to connect 3-phase system is called as delta connection. The connection is so named because it resembles the Greek letter delta. Let's have a look at the voltage and current relationship in delta connection. Now, in case of delta connection, voltage across each connection is same as line voltage. But in case of current across each element is different than the line current. If you apply the Kirchhoff's law and do some math, you will find that the line current is √3 times greater than the current in each branch of delta connected system. Generally, star connection is used where you need a neutral and two separate voltages, like our distribution system. Delta connection is generally preferred where neutral conductor is not needed, like our transmission of high voltage power. Also, delta connection is preferred where third harmonics needs to be controlled. Star and delta connection are almost used everywhere when we talk about three-phase system. You will generally find three-phase transformer connected in different combinations of star and delta connection. For example, star-star connected transformer is generally used as an auto transformer. Delta-delta connected transformer is generally used for high voltage transmission. And delta star connected transformer is generally used as a distribution transformer. Now, as we have studied the star and delta connection, a question can pop up. Power transferred by star connection and power transferred by delta connection is same or different? So let's find that out. Consider the star connected winding first. Apparent power transferred by a single phase is given by this formula. This is the power transferred by a single phase. To calculate the power transferred by three phase, we can multiply this equation by 3. So the result will be this. Similarly, apparent power transferred by a single phase of delta connection is given by this formula. Multiply this equation by 3 to calculate the power transferred by three phase, and you will get the same result as star connection. And this proves power transmitted by both the connection is same. So let's summarize this video. Three-phase system can be connected in two different styles, star or delta. In star connection, line-to-line current is equal to line-to-neutral current, but line-to-line voltage is √3 times the line-to-neutral voltage. In delta connection, voltage across each element is equal to line voltage, but line current is √3 times the current flowing through each element. And the last one, power transmitted by both the connection is same.